Okay, before we dive right into the very first algorithm, which is the naive algorithm, we'll go through some conventions that we'll use for all the algorithms under string matching. Okay, so conventions used. Okay, so firstly, we will just have P to stand for the pattern, and T is the text. So we want to find P within T. And let's say we have P as a character array that is of length M. And we'll have a variable called K, which is the current index of the character that we are at within P. Same thing for T, we'll just have a character array that is of length N. And we'll use J to point to the current character that we're at in T. Okay, so let's say for P, let's say is equals to DEF. Okay, then J equals to 2, and PJ will give us F. And it's the same logic for J. So to easily remember this, we can just have this abbreviation of PMK and T and J. And we'll refer back to this slide if needed. Okay, so now we'll jump right to the naive AGA, the brute force algo. So how it works is, let's say we are given P equals to ABC and T equals to maybe DEF ABC. Actually, let me make it a bit more complicated. Okay, let's say is maybe and then ABC. Okay, so what I can imagine is there is a wall to the left such that both P and T are stacked against this wall over here. And what we'll do first is, remember, let me write it over here. Remember there's PMJ and TNJ. So for P, you have the pointer K, and for D, you have the pointer J. So what we'll do first is compare K and J, like as in the characters at K and J. So in this case, they are clearly different. So what happens is that we'll move to the next alignment, aka the next window in T. So now, instead of being here, instead of J being here, J will now be over here. And now we compare the character at K and J. And since they are different, we'll move on to the next window, which is at F. And they're different again, so we'll move on to the next window at A. So from this, we can clearly see that what we mean by window, aka alignment, is, in this case, the window size will be the length of P. which is the value of m. Because remember, length of t is equals to m. And the length of t is equals to n. So the first window was initially this, and since the first character was a mismatch, we move on to the second window where there's also a mismatch, and then we move on to the third window and your fourth window and so on. So in this case, the window size will be n, which is of size 3. Okay, so back to what we were talking about earlier. Now we're at this window over here, and clearly we can see that the first character matches. So when the first character matches, what we do is we want to stay within this window. Okay, and in order to stay within this window, we'll need another pointer to keep track of where this window is at. So we have another variable called I over here. This allows us to increase j by 1. So now j is over here. And now we see that at the same time, what we do is when we increase j, we also increase k by 1. So now we compare k and j, and they both point to be the same character. So that means we increase the both of them again. So now j is here, and now j is here. And now we can see that they are both different characters, which is why this window fails and we need to check the next window. Okay. So when we want to check the next window, it will mean that we have to reset k back to 0, because we will need to start checking whether it matches the first character of p from scratch. And at the same time for t, we can see that j right now is over here. But then we need it to go to b over here. So how do we do so? That is what I was for. Because remember, I points to the current window that we're at. So since this current window fails, we need to move on to the next window, which is over here. Okay, so I points over here. And then what we can do now is we set j to point to the same place as I over here, which is what we want, because now we want to compare, in this case, this window BAB with ABC. Okay, so now we just compare the characters pointed to by k and j. So A and B is a mismatch, which is why we shift the window again. So shift the window in this case means we increase I by 1. And this is the last window. And in this case, I is here and j is here. Okay, so remember, G and J have the same character, so we increase them by 1. So it will be B versus B, it matches, C versus C, it matches. And remember, whenever the characters match, will increase. Will increase, in this case, K and J by 1. So we end up having J over here and J over here. So this is when we can stop the algorithm, because there is a match in a sense. Okay, but now you may be wondering, like, what if there isn't a match? So let's say we have, okay, instead of t being like this, let's say t is like this. Here's z, v, c. So obviously, like, this is the last window. So if we were to move to any character after the last window, then essentially the comparison would definitely fail because there aren't enough characters left in T to match P in the first place. So in this case, once J reaches here, there are only 2 characters left. But then P has 3 characters. So no matter how you think about it, it will definitely fail. Because 2 characters cannot match 3 characters. So in case P does not exist in T, and then we'll just return -1. Okay. Okay, so now I think we can jump to the code. Okay, so this is how the code looks like. Okay. Okay, so same thing we include. Okay, this language is in C, so we'll include this header file in order to use the printf later. And this is our function that will return an integer. So if it returns the integer of -1, it means that we cannot find a pattern within the text. But let's say if it returns integer, let's say 4, that means P can be found in T at index 4 because we are concerned with the first occurrence of P within T. And then, I mean, as you can see the comments over here, yeah, we covered what I, J, and K were just now. And over here, when you see is while J is less than or equals to N, which is the same thing as while J is less than or equals to N-1. Because remember earlier how I said that. Remember this is T, and then it has length of N. So that means the last valid index is N-1 because we use zero-based indexing. So if we will try to access, let's say Tn, then it will be an out of bounds error because the index n doesn't exist. So this will be, sorry, so, oops, okay. So this is not allowed. So this is why we wrote this. Yep, and you can imagine Tj over here. If, let's say if j were equals to n, then over here will be Tn, which will give an out of bounds error. Okay, but normally when we compare it now is, let's say if the characters at T and P are the same, then I mentioned earlier we increase both by 1. Okay, then let's say remember, okay, for this line is when K is equals to M, then we return I. Okay, so it's actually quite straightforward. So yeah, I'll just rewrite it over here because the top is a bit messy. Yeah, so this is the, okay, let's say if we run through our algorithm and we reach over here. Okay, so remember, whenever we move on to another window, we'll need to reset K back to 0. So in this case, let's say K is over here. Okay, and remember, the length of P is equals to M, which equals to 3. Right. And over here will be J. So you can imagine A matches A, B matches B. Oh wait, sorry. I actually made a silly mistake here. It should be over here. Yeah, it matches over here. So A matches A, B matches B, C matches C. Okay, so you can imagine that when we're comparing C versus C, it'll be like this. But if you were to look back at the code that we have, so when it comes to over here, they match. So we'll C matches C over here. So it triggers this if block. And then we'll increase both J and K. Okay. We increase both J and K. So over here, if you imagine increasing both J and K, then K will now be over here instead. So in this case, the value of K will equals to 3. Because initially the value of here was K equals to 2. So now K equals to 3, which is the length of P, which is M. And at the same time, J will increase to this over here. Okay, but the main focus is this. So from this, we can conclude that whenever J equals to M, it means that we have increased K all the way such that there are no more characters left in P to compare, which means that we have managed to find P within T. Okay, so this is why in the code over here, I wrote that if K equals to M, then we'll return I. And in this case, you might be wondering why return I, because remember, we want the index of the current window that we're at. So in this case, I will be over here. So in this case, it'll be 0, 1, 2, 3, 4, 5. Yeah, so in this case, I equals to 5. So our program will return 5, which is the index in which the first occurrence of ABC is in T. Okay, so this part is explained. And now the else part is what if the two characters don't match. Then like we talked about it earlier, we'll increase I first, and then we'll make J have the same value as I. Okay, so this is actually just the same thing as by increasing I by 1, and then J equals to I. Yeah, it's the same thing. So these two lines over here are equivalent to this line over here. Okay, because let me write it over here. Because like how I mentioned, just wait. Let's say if there's a character. Okay, let's say we are over here. Okay. And so A, B, but then C and A don't match, right? So at this point in time, like J will be here. J will be always here. But obviously J and J don't match. And remember the I is here. So what we do is, remember, we look at the code again. We see that increase I by 1 and then set J equals to I. Okay, so we increase I by 1, so now I points over here. And then we set J equals to I. Yeah. So I points to the new window. And we set J to I so that J is at the first character of the new window. And then remember to reset J back to 0 so we can compare this window of ABC against BAB. Okay, so we're explaining this. Okay, and then now this part. If J is greater than n minus m, we break. So remember how I said that when there are no more valid windows, sorry, not in the sense like there are no more windows left to check. So it's basically, let me see whether I can find it. Okay, let me just rewrite it over here. Let me think. Let's say if I just put it as ABC. Okay, so remember how this is the last window? And actually if there's no point increasing I anymore, because let's say I is over here. There's no point increasing I anymore because if we increase I, the next window is here. But then there are no more characters over here to check. So it's a definite mismatch in a sense. So if you notice a pattern, remember how we said the length of T is equals to M. Then length of T is equals to N. Sorry, this equals to 3. This is 1, 2, 3, 4, 7, 8. So this is 8. So remember the code said that if J is greater than N minus M, we break. So if in this case N minus M equals to 5, right? So 0, 1, 2, 3, 4, 5. So this is I equals to 5. So if in this case J is greater than index type in this case, so let's say if J is over here, then we break already, because remember, let me go back to the code actually. Remember what we do is whenever there's a mismatch, we increase I by 1 and then set J equals to I. Okay, so in this case, and K equals to 0. So this means that right now, J is pointing to the first character of the new window. So in this case, J is pointing to the first character of the new window, which is B. But then this new window only has 2 characters. But then, remember we reset K back to 0. So K has 3 characters. So 2 characters definitely will not match 3 characters, which is why we stop. Yeah, there's no point checking anymore, which is why we break. So once we break out of this while loop, we'll just return a -1. Okay, now what happens if, let's say, okay, let me just trust the pencil. Okay, if length of T is greater than the length of T, in other words, when M is greater than N, then this means that definitely P does not exist in T, because the entirety of T is lesser than that of P. So let's use a simple example. So if P is equals to ABCD and T is equals to ABC, then let's say we compare A against A, B against B, C against C. Okay, then it'll come to a point where, okay, let me just write it here. remember we are PMK, T, and J. So it'll come to a point where J is now over here. Then if we look in this case over here, we're triggering this part over here. So we do not trigger this if statement, but we do trigger these three statements above it. So this, this, and this. And so remember when C minus C, we increase J by 1, which is why J is over here. And then we increase J by 1. So in this case, J will now point to over here. And as of now, K isn't equals to M because K is 3 and M is 4. So yeah, this part over here isn't triggered. Like this, if K equals to M with an I statement isn't triggered. So that means we proceed to the next iteration of the while loop. And now we realize that J equals to N, which is why it will fail this check over here. And thus it will break out of the while loop. And then we'll return -1 over here. Okay, so this is the first scenario. Okay, the second scenario is when, let's say, P equals to A, B, C, D. Okay, and T equals to A, B, Z. And then, let's see, you come to the point where, yeah, let me just erase this first. Okay. J is always here, and J is always here, and they do not match, so we trigger this else block. Okay, so in this case, J will increase by 1, so now J becomes over here. Sorry, I said that on me. I mean, I will increase by 1, so I will now point over here, and J will equals to I, and J will reset back to 0. And remember now J is pointing to the first character of the next window that we need to check. And we realize that you trigger this part. Because remember, we have M greater than M. So that means in this case, let me think, M is greater than N. So N minus M will be lesser than 0. In other words, M minus M will be negative. So when N minus N is negative, now let me solve here. M minus N greater than 0. So if we were to set that, multiply both sides by -1, we get this. Yeah, so it's 4. So M minus N is lesser than 0. So that means we know that J is always greater than or equals to 0 because the least value that, because J is the index of the character in P that we are comparing, and the lowest index is 0. So J is always positive. J is always greater than or equal to 0, which means that in this case, this statement over here will be triggered, and thus will break out of the while loop and will return -1 over here. Yeah. So this is why the code that you see on the right hand side over here actually already implicitly handles the two cases when N is greater than N. Like normally during the exam, at least I myself, I would just write a additional statement at the top saying that if, let's say, m equals like let's say after this, well, like maybe you can actually like write a chat over here. If m is greater than n, then we just return -1 right away. Then we do not need to check this whole while loop over here, in a sense. Yeah, so you can do that as well, whichever is more comfortable for you. Okay. Now we can move on to the next part, which is the time complexity. Okay, so when talking about time complexity, we normally talk about the worst case. So the worst case is normally when both pairs are the same, except for the last character, or key does not exist within key. So it's either P not in T or P in T, but only at the last window. So let's say if both of these cases are actually the same time complexity wise. So let's say if that there. So 5 plus 7, so n equals to 12. Over here, m equals 5. So in this case, is when p is not in t and we need to do m comparisons for every window. So that means for the first window, we need to do 5 comparisons. For the second window, we need to do 5 comparisons, so and so forth. So that means the number of, normally the time complexity is equals to the number of iterations times the time complexity. Sorry, let me just write here. Overall time complexity is equals to number of iterations times time complexity iteration. So in this case, we measure the time complexity per iteration in terms of the number of comparisons per iteration. So in the worst case, it will be O of m. So how do we find the number of iterations? So the number of iterations is basically, actually let me write here, number of iterations is the number of windows, the maximum number of windows. So what's the maximum number of windows? If we see over here, there's 1, 2, 3, 4, 5. This is the last window, right? Okay. And how many windows can we have? It'll be 1, 2, 3, 4, 5, 6, 7, 8. Because that means I can range from 0 to 7. This is 1, 2, 3, 4, 5, 6, 7, 8. So that means 8 different windows, which is actually equal to m minus n. Sorry, the other way around. N minus m plus 1. In this case is 12 minus 5 plus 1 equals to 8, which is why is n minus m plus 1 times O of m. Yeah, okay, remember this one is because we measure in terms of number of comparisons. Okay, so this final result, it basically is equals to O of n. So this is the worst case type complexity for this brute force method. And remember, n is the length of P and n is the length of T. Okay, so that's all for this algorithm, and I'll see you in the next one. Later.